Well, the topic of this lecture is basic computational structures of C language. Computational statements, assignment statements, comparison statements that we considered on previous lesson can be, from some point of view, considered as bricks for construction the building of C program. But as we compare with real buildings, any building is built by standard bricks. So all the variety of the algorithms can be described by means of three main bricks, three main basic computational structures. These structures are sequential structure, selective structure, and loop structure. Such approach is called the paradigm of structural programming. Because when the programming languages 50 or 60 years ago was developed, the developers think about it. What computational structures should be included in programming language? And it was proven theoretically that it's enough to use only three computational structures: sequential, selective, and cycle, to describe any algorithm. And from this point of view, the programming can be considered as a puzzle. We take these three standard constructions and assemble them in a whole program. Any program is built by means of these three computational structures. The most simple structure is a sequential structure. In fact, any function in a C program, including the main function, is represented as a single sequential structure. The individual statements in this sequential structure can be complex and can implement more complicated order of actions than simple sequential one. The meaning of sequential structure is very, very simple. So if we have several statements, then these statements are executed in sequential order, one after another. The graphical illustration of the sequential structure is as follows. It's very simple. Statement number 1, statement number 2, and so on, statement number 3. All of the statements are executed one after another. From the first point of view, it's obvious and very simple that statement number 1 should be executed before than statement number 2. But this sequential order of execution of the statements will be true only for sequential programs. And it's not true for parallel programs. I think you know, and everybody knows that all of the modern computers are parallel. If you take any computer, notebook, even a smartphone, the central processor of this device contains several computational cores. These cores can carry out several statements in parallel. It means that the order of execution of the statements in parallel program is not sequential, but parallel. For example, 10, maybe 8 or 4 statements can be executed at the same time. Not one after another, but at the same time. But during our course, we consider only the first, the simple case, sequential programming, and in this case, statements are executed in sequential order, one after another. Let me switch to Visual Studio. Where is it? It's here. It means that when you write several statements, just output statement, for example, then statement number 1 will be executed before statement number 2, but not in parallel. Okay, this is the most simple case of computational structure. The next and very, very important case of computational structure is the selective structure, if-else. This computational structure realizes one of two alternative statements according to the result of checking some condition, which has two possible events, two possible outcomes. The one outcome of the condition we can denote as yes, another outcome as no, or true and false. So these possible results fully corresponds to their Boolean type, logical type, that can have only two possible values, true and false. The selective structure contains two branches, only one of which is carried out. The general scheme of the selective structure can be represented in a graphical form as follows. First, we check the condition and obtain the result of checking the condition. If this result is yes, we execute the statement number 1. If this result is no, we execute statement number 2. So statement number 1 and statement number 2 are alternative statements, and they cannot be executed at the same time. Only one of these statements will be carried out. And after this, program continues. So what statement to execute depends on the condition. Will it be true or false? In C language, such computational structure is realized by means of the following statement. If after that some expression in parentheses and statement number 1 after their expression. Else statement number 2. Here exp is some expression that will have logical result. In usual case, this expression is just a comparison expression, but in more complex cases, the expression can be a logical expression that uses some logical operations. But in the very simple case, this expression is just a comparison. But again, we can use any kind of expression that will have a logical result. And the result of this expression determines which of two statements must be executed. If the result of this expression is true, then statement number 1 is executed. If the result of this expression is false, then statement number 2 is executed. Let me remind you that false can be considered as 0. 0 means false, false means 0. 1 means true, true means 1. Or generally speaking, 0 means false and not 0 means true. Any value that doesn't equals to 0 corresponds to true. On the next slide, you can see some examples. If then, if else statement. Here also some examples, but maybe I just copy and show you these examples. In Visual Studio. Let me declare two variables A and B. And I want to output to the screen the largest value between A and B. I should write if A smaller than B. Sorry, if I want to output the largest, I should write something like this. If A is greater than B, then I output A, the largest value. If B is greater, so it means if this condition is true, we output to the screen A. If this condition is false, we output to the screen the value of B. And if the initial values are 0 and 10, we will see on the screen the message that max equals to 10. I can select the largest value on other way. Let me declare one more variable, m, and let me output the value of m after the if statement. And inside if, I just assign here m to A and m to B. It means that if this condition is true, then I assign the value of A to the variable m. And in other case, if this condition is false, I assign the value of B to the variable m. And after that, I'll output to the screen the value of m. M will be 10. If I assign, for example, -10 to b, in this case, this condition will be false, and the second branch of if statement will be executed, and we will see on the screen the message max equals to 0. Okay, but what happens if these values are equal? This condition will be false. 10 greater than 10. Is it true? Not. It's not true. That's why the second branch will be executed. And again, we will see on the screen the message that the value of maximum equals to 10. Max equals to 10. I can use any kind of comparison here. Less than, greater than, less than or equals. Of course, it depends on the algorithm. If I will use here less than, in this case, this if statement computes not maximum, but minimum. For example, if a is 1, b is 10, this condition will be true, and this branch will be carried out, and we will see on the screen the message min equals to 1. Well, and I just write some example. I can use here any kind of logical expression. Any kind of logical expression. For example, if a and b and true. If a and b or true, and any kind of logical expression I can use inside their statement, inside this statement. Well, very important feature is that after if and after else, we can write only one statement. According to this general description, we can write only one statement. For example, if I write here two statements, the second statement doesn't belong to the branch else. It corresponds to the main. And we will see on the screen the message that minimum equals to 0. Because this operation doesn't belong to the else branch. We will see on the screen the message min equals to 0. But in the case when it's required to carry out several operations inside if branch or else branch, in this case, it's better to, not better, but it's required to write figure brackets here. And it's obvious to write figure brackets, and we need to include all of the statements inside the brackets. For example, let's imagine that I want to output to the screen the square of smallest value. Not the initial value, but the square, the value raised in square. It's very simple. Let me write here this value and the second statement. A squared equals to m. And inside else branch, I write the same, but here I use b. B squared equals to m. So now any branch contains two statements, and these statements are enclosed in figure brackets. So the good idea is to write figure brackets always when you write if and else. Let's run this program, and we see the message a squared equals to 1. Yes, it's correct because the value of a is 1. If I assign 2, we will see on the screen the message a squared equals to 4. Well, don't forget to write figure brackets when you write if and else. If you forget to write it, in this case, only the first statement will be included in the else branch. The program still be correct. If I try to compile it, look, compiler outputs me succeeded. No mistakes. The program correct. But what will we see on the screen in this program? We will see on the screen two messages. A squared equals to 4 and b squared equals to 4. Two messages we will see on the screen. Because the second statement, second cout statement, it doesn't belong to the branch else. It's outside of it. Only the first statement belongs to it. So don't forget to write figure brackets. Well, let's switch to the presentation. I'm really sorry. Sorry. We continue the lesson. Well, yes, the one remark that no semicolons here, only inside if statement you should write semicolons. And the next feature, you can use a nested selective structure. If inside if, suppose that I want to decide, I want to output to the screen different messages when the numbers are equal. I write more or less the same example in Visual Studio. In this case, if a smaller than b, I output a square. Else, here I can write another if. If b greater than a, then I output to the screen b squared. Else, the last case is that a equals to b. So if this condition is false, and if this condition is false, only one possible case can be that a equals to b. Then I compute m squared and let me output the message a equals to b squared. So if this false, if this condition is false, if this condition is false, then this branch will be executed. Here I use if statement inside this if statement. Let's check. If a is smaller than b, we will see this message on the screen. A squared equals to 4. If not, for example, let me assign 12. 12 is greater than 10. Or, sorry, this condition should be, of course, not if a is greater than b. Like this. If a is greater than b. And if a is greater than b, then sorry, I should turn off your voice. Please, yes, yes, thank you. Turn off your microphone. Well, if a is greater than b, then we will see this message on the screen, b squared. We will see b squared equals to 100. Okay. And if these two values are equal, we will see on the screen the message a equals to b squared equals to, in this case, 124. 12 and square equals to 124. Sorry, not 20, 44, of course, 44. 144. Well, this is just a simple example of the nested if structure. If inside if. Okay, let's switch to the presentation. And the next feature of if statements is a shortened selective structure. Sometimes it's convenient to apply the scheme of partial choice when the statement 2 is empty. It means when this condition is false, the branch no corresponds to the action do nothing. This scheme can be shown on the following diagram. If the condition is true, the statement number 1 is executed. If the condition is false, the program does nothing. Let's check and let's look to this into Visual Studio. In this case, I can skip the branch else. Let me just comment it. I don't want to delete it. I just comment it and close this comment. So my program now contains only branch if A smaller than B. For example, if A equals to 12 and B equals to 12, A smaller than B, the result of this comparison will be false. 12 smaller than 12 is false. So we will not see on the screen nothing. No messages. Program just finished. But if this condition will be true, for example, A equals to 10 and B equals to 12, then we will see on the screen the message. So in this case, only the first branch, the branch if, will be executed. Okay. This is just an example. I skip it because it's more or less the same. Well, and the next selective statement that I want to show you this lesson is the multiply selection statement, switch, case, and break. The statement if and else allows us to take a choice between two possible alternatives. But in some case, it's necessary to select one alternative among several ones. In this case, we can use a special statement switch. The general form of the switch statement is presented here. Switch, then expression, and after that, in figure brackets, I should write case constant number 1, statement number 1, break. Case constant number 2, statement number 2, break, and so on, up to constant number n and statement number n. How it works? Here, the item expression is an expression value of which determines the variant to be selected. Constant number 1, number 2, number n are integer valued constants. Statements number 1, number 2, and so on, and statement default are statements, one of which will be selected for execution. Every branch after internal statement can contain the special statement break. But generally speaking, break is optional. Usually we write it, but it's optional. the variant default may be omitted. How it works? First of all, the value of the expression is calculated. Then we check if this value does it equal the values of constant or not. If the value of the expression coincides with one of the constants, number 1, number 2, number n, the statement corresponding to this constant is executed. And if the branch is ended with the break statement, the switch completes its execution. So if the value of the expression corresponds to the constant number 1, then statement number 1 is execution and the switch breaks. If the value of the expression corresponds to constant number 2, statement number 2 is execution and the switch breaks, and so on. If the value of the expression doesn't coincide with any constants, then the branch default is executed. And if the branch default is omitted, the selective structure does nothing. Here is some simple example. Suppose that the students wrote the test on programming and professor developed a program which inputs marks of the students numbered from 2 to 5 and prints the results in a verbal form. If we suppose that the mark of the student is stored in the variable test result, then the program should contain the following switch statement. I just copy this switch to the Visual Studio. Suppose that I have a variable test result. Test result equals to 4. So I should use another brackets, not the brackets that is written in presentation. This one. Okay. And let me write break here after each statement. Well, how will this program works? Test result equals to 4. Test result equals to 4. 4. Is 4 equals to 5? No. Is 4 equals to 4? Yes. And the program outputs to the screen message good, and the switch breaks. So in the end of this program, we will see on the screen the message good. Let's check it. Yes, you will see the message good. Let me write here end of line. End of line, end of line, and one more end of line. Okay, if the test result is the value of the test result is 3, then we see on the screen the message satisfactory. Okay, what happens if the test result will be -1? -1 doesn't correspond to any constant. we will see on the screen nothing. In this case, the branch default can be used. If the value of the expression doesn't correspond to any constant, the branch default is executed. So in the case of test result equals to -1, we will see on the screen the message wrong mark. Wrong mark. Well, I think you understand how switch works. Some final remarks about switch. Here, I can write not just the value of the variable. Value of the variable is an example of simple expression, or even primitive expression. But I can write here any other kind of expression, like this. Test result +1. In this case, if the value of the variable test res equals to 4, then we will see on the screen excellent, because the value of the expression test result +1 will be 5. We'll see excellent. If test result equals to 5, what we will see on the screen? Wrong mark, because here the result of the expression will be 6. This is one more feature of switch, and maybe one more feature. What happens if I delete here break? Suppose that I forget to write it. I forget to write here breaks. The program still be correct. I can compile it and I will see the message succeeded. Well, according to the description that is written here in the presentation, and it's written in any book on programming, if the break is absent, the next case statement or default statement is executed up to the first break or up to the last alternative. So if the break is absent, then switch doesn't breaks, and the next statement will be executed. In this case, if test result equals to 5, we will see on the screen the messages excellent, good, and satisfactory up to the first break. This break interrupts the execution of switch. Let's check it. And we will see these 3 messages. Up to the first case or up to the last alternative. For example, if I delete here break and I have the value of the test result 2, then we will see the messages poor and wrong mark up to the last alternative. But of course, in the most cases, the breaks are very useful here. And the general rule is don't forget to write a break in the end of the case statement. Well, actually, you can organize your program in this way, and you can write here several statements. any statements that you want. For example, test result equals to 0. Let's change the value of the test result. We will see on the screen the message excellent, and after that, test result becomes 0. So you can write here any statements that you want. This is the first remark, and the second remark. In the case statements, we can write only constants. Here, only constants can be written. These constants can be literal constants, just some values, or it can be named constant. Let's declare the constant const int, for example, good equals to 4. Let me declare the constant with their identifier good and the value 4. Now I can use this constant here inside a case. And if test result equals to good, the value of this constant, we will see on the screen the message good. But pay attention that only constants can be written here. If I declare the variable good, this variable cannot be written in the case statement. Only a constant. Generally speaking, not only a constant, but a constant expression. So what is the value of good 4? I can write here as 2 plus 2. 2 plus 2 is 4, but these 2 and 2 are constants. And 2 plus 2 can be considered as a constant expression. And the program, in this case, correct. We will see on screen the message good. I can use a named constant, for example, good plus 2 minus 2. So I add 2 and subtract 2. So the value still be 4. Good. The program is correct, succeeded. And if I run, I will see the message good. Well, in cases, you can use only a constants or constant expressions. No variables can be used. And only a constant of integer type can be used here. Only integer numbers. You cannot use real numbers, float, double. You cannot use strings. You can use char, because the data type char has a dual nature. In one case, it corresponds to symbol. In another case, it corresponds to character, and the code of the symbol can be considered in this case. But float, no. Double, no. Only integer. Well, let's come back to the presentation and well, just a remark that you can write several statements inside this case. That's all that I want to say about the selective statements, if and switch, and the next lesson, next Thursday, we will consider loops. We will discuss about loop structure and we will consider some examples of the programs with loops. That's all. Do you have any questions about our lesson? Well, 5 students are here. It's good that 5 students are here, but it's not very good that you connect to our meeting not from the very beginning, but just in the end of the lesson. Well, let me stop recording.